Hi everyone, I hope you are having a lovely day. So this talk, it will be a little bit technical. I will try to uncover some technique to perform some uncommon and advanced techniques to perform account takeover, especially against web applications. So before we jump in, let's start by introducing myself. So my name is Ayoub. I am originally from Morocco. I have an engineering degree in computer science. I have been a pen tester for over a decade now. Currently, I'm working as a senior security consultant at MDSec, where I engage in security assessment with different kinds of clients. Also, I am a bug bounty hunter, but only like in free time. And I have been doing bug bounty hunting since 2014. If you want to reach me, this is my Twitter handle. So some disclaimers. So please don't break the law. Be nice, be ethical, and of course my opinions are my own. So in this talk I will try to highlight some techniques and base my experience as a bug bounty hunter. So what is an account takeover? Basically, an account takeover is an attack where an unauthorized individual take over another user's account, thus enabling them to impersonate that user and even like sometimes access that user's sensitive information. So these kind of attacks have like serious consequences on both individuals and organization. So why account takeover? Basically, it's been considered an attack with high security till critical security impact. Also, these kind of attacks are not easy to be detected by firewalls, since they are not like normal attacks like payload-based attack like SQL injection and XSS. This kind of attack requires some analysis and some understanding of the logic of the application, so you can find your way for discovering this kind of attacks. Also, there are multiple ways. All depends on the context and the application logic. And from the bug bounty perspective, it's handsomely rewarded. As you can see, Facebook pays out $40,000 for a security researcher who was able to share multiple vulnerabilities and perform an account takeover. So, entry point. Well, this is OWASP Juicy Shop. Is a web application used for like practicing the OWASP top 10 vulnerabilities. So, as you know, like there are many ways for a user to access their accounts. So, they can the primary way is by the login form, like using the combination of email and password. There are, of course, other ways, like if that user has a social media account, they can use what we call OAuth protocol and authenticate to their accounts. Also, users can even create new accounts by following the registration process, or even in some cases that user forget their passwords, and they can do what we call an account recovery process, where they will receive some reset tokens, and then they can create new passwords. So since we have many ways to access an account, then we have many ways to perform an account takeover. So for example, account takeover targeting the login process, let's call them login takeover. So we have login takeover, registration takeover, password reset takeover, session takeover, and OAuth takeover. So in this talk, I will be only focusing on login takeover, session takeover, and password reset takeover due to the limited time frame. So let's start with session takeover. So we all know that our web application maintains the state of a user account using what we call the cookies. Basically, they are just a data in the form of string that are being stored on the client side. So one way to implement those cookies is by using what we call a GWT. So if you are not familiar what is a GWT, is basically it's called JSON Web Tokens, basically an open standard for transmitting for securely transmitting data between different parties as a JSON object. And you can identify this GWT by looking at the first three characters which start with E, Y, G. So this is just, it does look random, but this data is basically just a base 64 encodation for three JSON objects. So if you decode this GWT, you will get this kind of a formation. So you will have the first JSON object, which called the header. Then you will find the point, and then the next JSON object and the third one. So let's understand first how GWT works. So when a client sends a request with GWT as their cookies, the web application will first start by encrypting the header and the payload and using what we call HMAC function. Basically, it's a combination of hashing and symmetric encryption. And then it will calculate, it will encrypt the header and the payload using a secret key that is only accessible from the application side. And if we have a match for the signature with the one calculated and the one provided by the client, then we know for sure that this token is a valid one. Otherwise, it's not acceptable. So this token is consists of, as we said, three JSON objects. The first one is a header. The header is where we define our encryption algorithm. Also, in the payload is where we define some information related to that token itself. For example, we find the expiry date, the admin or the user ID, if is it admin or not. And finally, the signature. So this implementation of cookies is widely used nowadays for many reasons. One of them is performance. So when using normal cookies, the application needs to do some database lookups because a cookie is basically just a normal, a random value. So then it will go to the database, check if that cookie exists, and then will fetch the user ID associated to that cookie. And when dealing with a lot of users, it will take, of course, a lot of time, so it's not that practical. So when using GWT, all the information that we need about the user are already in the payload. You will find the user ID and the username. So you just need to verify if that token is not being forged by a malicious actors. So let's see some bad implementation for this GWT. Sometimes developers forget and uses the null algorithm. When using the null algorithm, for example, if you use null algorithm instead of this algorithm, the GWT doesn't require a signature, meaning anyone can forge valid GWT, thus impersonating other users' accounts. Meaning you can put anything here, like for example, instead of using your ID, you might use that victim ID and then access their accounts. Sometimes we might find confidential data, especially details about that user. And even sometimes developers tend to use weak GWT, which are brute forceable. And even sometimes they don't check this signature at all. So this is some common misconfiguration. Now let's see some uncommon misconfiguration. Also, if you are using Burp, this is a great tool called JSON Web Token Attacker. Basically, it will highlight any HTTP request with the color purple that contain a GWT, and also it will allow you to perform those common attacks, like for example, switching the algorithm with null. So, before we dive in this uncommon vulnerability, I want to share my experience as how I was able to discover it. So, this was a web application that belongs to one of Targeted that running a program in HackerOne. And I'm hiding these details for respect of the NDA. So, but I will try to but it's showcasing how this application works. So, as you can see, this web application interacts with an API, and this API endpoint it only tries to fetch the user details. And this is the cookie being used, and basically it's just a GWT. And as you can see, this is my ID. And this is a production, an application hosted in a production environment. So, if you decode this GWT, you will find that it contains information like the ID. So basically, the application takes this ID and it will fetch that user based in that ID. So I tried every common misconfiguration. I even tried brute forcing some secrets, but with no success. So I decided to take a step back and see if I can find any issues in other assets that belong to the same target. So then I found a similar application, but this time is being hosted in a staging environment. And this is a register request where you can create an account. As you can see here, this is the same token, but this time it's been used for a different kind of application. But it uses the same mechanism of handling the cookies. So if you decode these cookies, then you will get this information. This time, the ID is 538, which does look interesting. So from this information, it tells us basically that those applications are not using the same database, which is like common sense. However, the question here, what happened if I use this GWT in the production environment? And then you have access to the user 538, but this time in the production environments. It appears that both applications are using the same encryption keys for encrypting GWT, which is like considered to be critical. Since now, basically, if you do the math, I can hack more than 12,000 accounts using this issue. So for this issue, it was assigned as high because normally it's supposed to be critical, but the registration process is protected by CAPTCHA. But nevertheless, I got like a nice bounty for it. So this attack, I call it GW reuse attack. Basically, you try to reuse a GW token from another source and use it in the target. So there are different ways to find this valid tokens. For example, as we say in this example, staging environments, sometimes similar web applications, like even if they are hosted they don't similar, but sometimes the same company or developers use the same encryption keys. Even GitHub is your friend. For example, you might find that company is hosting a project that is being accessible publicly, and sometimes you will find GW secrets key that can be reused for other applications that belong to that target. So now let's move on to login takeover. So in this topic, we will not uncover an uncommon technique, but we will see a way to perform this attack, which is a credential stuffing attack. So credential stuffing attack basically is when an attacker tries to get a collection of stolen credentials that can be retrieved from data breaches, or even they can buy them from the dark market. So, and this attack relies on the fact that this victim might use the same credentials for other services. So, I believe everyone is familiar with Have I Been Found, which basically you enter your password and see if that password is being exposed in one of the data breaches. So my question here, is there a way that we can get other users' passwords, without tracking down data breaches and well, the answer for that question is yes, and it's very easy. Well, there is a website called intelx.io. Basically, this website is a collection of a lot of data breaches. And what's cool about this website is that those data are being indexed, and this website have a really cool search engine. So you basically can put an email address and see if you can get any password associated with that email address. So in my case, well, you'll find I have been using this password, which is stupid, but I was only using it for relevant websites. But you can try that and see if you can find your password or other someone you want to hack password. So yeah, so you might find this password in a clear format or in a hash format. So it depends on the data breach. And another way to find this kind of password is GitHub. GitHub is a really awesome source for Usenet. You will find a lot of information if you want to collect information and to perform enumerations. For example, you can see this is a full database dump, contains email with the associated password in a clear format. So you might want to keep an eye on that. Yes, so this is an example from the bug bounty perspective. I was able to find credentials in one of a target users. And using those credentials, I was able to access their SharePoint instance, where I was able to find some really juicy information related to their business and even some information related to their clients. So now let's move on to password reset takeover. So basically, password reset takeover is, or password reset is a mechanism where users who forgot their password can still access their account by creating new passwords. And for that, developers tend to use what we call tokens. This token basically is supposed to be random and not guessable, otherwise it will not be practical in this case. And one way to implement these tokens is by using what we call a GUID or UID. Basically, GUID stands for Global Unique Identifier, and UID stands for Universal Unique Identifier. GUID is being used a lot with Microsoft ecosystem, and UID for other platforms. So let's stick with using GUID since it's easy to pronounce. So yes, so GUID are a way, instead of using ID, you use a value that is difficult to brute force and is difficult to guess. And did you know that there are different versions of GUID and UID? So for example, you have version 0, which is all 0. This is being used a lot in testing purposes. Also, you have version 1, version 2, 3, 5, and 4. So how can we distinguish a version of GUID by just looking at it? Well, there is a way actually. So if you take the first number after the second hyphen, it represents the version of that GUID. And there is a problem specifically with version number 1. Version number 1, it's a time-based. Basically, it's using the time of the system where it's being generated. So let's take a look up at the algorithm responsible for generating this version. So you will find that this version, basically, the 3 parts of this GUID are the timestamp, and the last part is just the MAC address of the host where this GUID was generated. And there is some open source services where you can just put an UID and decode it and take back information about the host from which this token was generated, the timestamp and also node which represent the MAC address of that host. So since this version is guessable, we can then guess other users' tokens. To do that, there is a great tool called UID tool. So basically, to use these tools, first we need a valid GUID value. This can be generated by using your account. So you try to create testing account, then do a request for password reset, receive the token, and copy it in here. Then you will try to use the victim email address and request a password reset for that victim. And while doing so, you will take into consideration the date for performing this action. The date can be retrieved either from sometimes the web application, there are some headers where it contains the date value. Otherwise, you can use your local date. So by providing these two values, this tool will generate possible GUID's value, which of them can be the token needed to reset that victim account. Yes, this is a real-world example of reset password link, and as you can see here, it's using the version number 1. So it's being used in the wild, so it's wise to keep an eye on it. Yes, and thank you. I hope you learned something new from this talk. If you have